look at the global economy, it is so dependent on international connectivity and international communications. The modern day life of social media, entertainment, video, the financial services, cloud services, they are all so dependent on international communications. One of the fundamental building blocks of international communications are submarine cable systems.
Subsea cables carry around 97–98% of the world's data.
When a cable goes down, there's a lot of pressure to find the location of that cable. Cable repair ship, for example, will cost around $80,000 a day.
The first transatlantic cable was built about 150 years ago, and it could carry 3 to 7 words per minute.
A single message would be sent via Morse code or telegraph.
If we fast forward to today's fiber optic cables, we can stream 1.5 million 4K videos with that same fiber.
Landing in countries with a total population covering 3 billion people.
Vodacom is creating a ripple effect of opportunity, representation and empowerment across the continent.
There's been geopolitical tensions and security risks in the Red Sea.
About a week later, a mudslide occurred on the west coast of Africa, so we'd lost about 80% of the subsea cables around the African continent. It's ever-changing, ever-evolving. The growth I've seen since I've been here is phenomenal.
Subsea cables carry around 97–98% of the world's data. This data can range from anything from video conferencing, emails, all the way to financial and security type traffic. So I'm one of 3 engineers at Vodafone who are responsible for the operations and maintenance of our subsea cable network. So that consists of 11 wholly owned or consortium-owned cable systems and about 16 cable landing stations. The journey of data through a subsea cable happens at the speed of light. It begins when an end user, a customer, requests a piece of information. So this can be sending an email, streaming something on social media. From there, that data, that request is sent via our fiber network on the land into data centers and then ending up at a station like this. It then travels through our subsea network over to places like the States, when then it reaches the cable landing station at the other end. Here it goes back through the fiber network, through to data centers and back to the other end users. And if a response is required and has to go all the way back, happens in a fraction of a second.
I'm the subsea cable station manager for all of the UK cable stations that Vodafone has an interest in. I'm part of the wider team that manages Vodafone's global cable stations. Yet we maintain 5 cable systems that land here in Cornwall. We operate the Network Operations Centre and we're responsible for the capacity allocation. We fix any faults that we experience on those cables. When a cable goes down, there's a lot of pressure to find the location of that cable because we have to do a lot of tests and we have to work out where the cable is and try and put the ship as close to the break as possible. So when you give the go-ahead for a ship to steam out into the middle of the Atlantic Ocean, it's going to take them 2 weeks to get there at $80,000 a day. You don't want them too far away from where you think the break is. So it's always a little bit worrying until the ship turns around and says they've got the cable and it's on board. And then you can breathe a sigh of relief and say, we were close. So, but it's, even though you've got the test equipment to do it, you still always have that little niggle in the back of your mind. Have I sent them into the wrong place?
I'm a principal submarine cable engineer working for Vodafone. And my role in Vodafone is managing and delivering Vodafone submarine cable interests around the world. So the industry, since I've been working in it, has evolved rapidly. And most recently, a lot of the drivers to cable projects have been the hyperscalers. We all consume data. We take it for granted. The growth of AI and the machine learning is only accelerating that. So most of the projects that we work on Vodafone are working alongside hyperscalers that are involved in that sort of industry.
I am the General Manager for Marine Operations for Alcatel Submarine Networks. We design, manufacture and build all assets of the telecommunication network and provide it to our customers, install it, and then we actually maintain it as well. So we provide maintenance vessels that look after the systems after they have been installed. The technology that we manufacture here in Greenwich are the repeaters. the optical amplifiers that regenerate the signal, and this is the repeater housing area, where the repeaters themselves, once the components have been assembled, built and tested, are then housed into the repeaters themselves. They're then transported over to Calais to our cable factory for integration with the cable before loading onto the cable ships.
I'm responsible for the commercial engagement and strategic development for subsea solutions and services within Ciena in a global fashion. And with that, we are helping hyperscalers and network owners increasing and scaling their networks on a global basis. So Vodafone Business and Ciena is working together on a number of subsea projects. The partnership aims at leveraging Ciena's advanced transmission technology with Vodafone's extensive network.
So south of England is really important for subsea history and specifically Vodafone's history as well in subsea telecommunications. Our other site here in Cornwall landed the first telecommunications telegraph cable in the 1800s and really marked a cornerstone of subsea telecommunications. So that began with the Eastern Telegraph Company, which then became Cable and Wireless, which obviously then became Vodafone. So that history sits with us and our company.
The Greenwich site itself has been involved in subsea cable technology since 1860. This site was involved in the company that developed the 1865 cable, which was the first transatlantic telegraph cable that was installed between Valentia in Ireland to Newfoundland. And that was really the start of what could be, interconnectivity between countries, etc. Before that time, it would take weeks to get a message from the States to Europe.
When the first cable was installed, it was a purely telegraph cable, no fibre optics at all. We turned to fibre optics. So one of our first cables of... Yeah, it's fun. Callum, do you need to come out? Yeah. Yeah, I've just been told the test was satisfactory, Callum. So they've just completed a joint in between. So they've jointed the repeater onto the cable. So they're testing the continuity through the stations. So yeah. There are various reasons why I'd come down to the station here in Cornwall. Most of the time it'll be due to some sort of maintenance activity or an installation of a new cable system. So if we're doing a shore end of delivering a new cable here, or if something's gone wrong in the land route or with the equipment, I can come down to supervise that work. But I also come down to train the apprentices, run courses, or attend training myself with the equipment here. Every subsea cable system has its own network operating centre, so its own NOC. Each NOC for each cable monitors the traffic, the powering, everything like that in between on a day-to-day basis, just monitoring all those levels. Part of that monitoring also falls down to the station staff.
In the station, we have 8 permanent members of staff, but we work with engineers all over the world and in other teams around the country. We're regularly in contact with the other station engineers at the far ends of the cables we're working on. We work closely with the engineering team in London that work on the marine side while we do the operations of the cable stations. We monitor the traffic flow for alarms on the system, so we'll pick up alarms pretty quickly when something goes wrong. And then we can analyse those alarms, identify where the fault is and start to fix it. The riskiest area by far is the power. A powered cable system requires high voltage, and the power feed equipment is on the ends of all of the cables here. So we're sending up to 15,000 volts down the cable. So you need to be a little bit careful when you're touching it. The worst that could happen, the worst scenario for us is a subsea cable break where traffic is completely down, an equipment failure on a major piece of equipment that could affect all the traffic. But that's what we're here to do, is to fix those static faults.
We work globally within consortiums, so that's across Asia, Africa, United States, Europe, and that often means for each subsea cable system delving into a working group, either in construction, maintenance, marine, financial, where experts in their fields from those parties will come together and drive the construction or the maintenance of a subsea cable.
The global collaboration is paramount for anything within the subsea world. Obviously, subsea cables connects countries, connects continents, which means we are dealing with different legislation. Therefore, having partners in each country is very, very important.
We have to work collaboratively to deliver the projects. They're very complex. There's a lot of people that have to come together to make that happen, and it's a very exciting process, involving a lot of skills.
The most recent collaboration with Vodafone has been the To Africa cable system.
It's the longest cable in the world by far, and the logistics of landing that with the amount of landings all around the coast of Africa, through the Med, into the Gulf. Yeah, the sense of achievement when it landed in Cornwall after the years it took to complete the project was immense.
It's actually a project that Vodafone instigated. The Vodacom operating companies in South Africa, in Mozambique, in Tanzania, in Kenya required economic connectivity to the internet.
During my time at Vodafone, I've been very active on particularly the To Africa cable system, working with a lot of investing partners, building a submarine cable system around the African continent, working very closely with our Vodacom colleagues in South Africa, Mozambique and Tanzania.
The connectivity that To Africa supplies to the continent is actually quite significant. From a cable system perspective, there's never been something like To Africa in Africa.
Well, this has certainly been a momentous project in many respects. I mean, first of all, it's the largest in terms of length, almost 45,000 kilometers, landing in countries with a total population covering 3 billion people.
At Vodacom, we see the To Africa project not just as a technological milestone, but as a platform for inclusive growth. The international connectivity domain demands a wide range of skills, from engineering and data analytics to logistics and network operations.
Well, the challenges range from bad weather, some technical challenges to get the system implemented, cable breaks occurring during the installation period. There's been geopolitical tensions and security risks in the Red Sea.
In 2024, a ship sank in the Red Sea and it cut 4 cables around the east coast of Africa. And about a week later, we had a mudslide under the sea on the west coast of Africa, cutting another 3 cables, one of which was the To Africa cable that we were still laying and was still live in parts. So to get the capacity rerouted away from that area to keep traffic flowing was particularly challenging.
So resilience is incredibly important and increasingly important with the geopolitical difficulties that we are facing, particularly in a global industry like ours.
Globally, each country, and particularly island nations, are active in ensuring that their cable systems are protected from external aggression as best as possible. No anchoring zones, cable protection zones. And it's very important that governments work proactively to ensure these items of critical infrastructure are given protection from external aggression and from actors who may be deemed as a threat to the submarine cables, and therefore the resilience of the telecommunication systems in each of those jurisdictions.
So for subsea cables to be resilient, it's not just about encrypting the data, it's about the cable itself and how we can ensure that lasts as long as it possibly can. So closer to shore, we armour the cable to protect it against fishing, anchoring, things like that, but then we also bury the cable during installation.
When you have to plough a cable into the seabed, you can achieve maybe between 14 to 20 kilometres a day progress, which is a relatively slow period. Thereafter, at about 1,500 metres water depth, which is currently the level at which the fishing threats are, we surface lay the cable along the contours of the seabed. And we have to ensure that there's appropriate cable slack to fill in the valleys and mountains that on subsea floors that you've got across the ocean. If things go wrong and we have a cable failure, or as we like to say, a cable fault, be it external aggression, or be it an actual fault itself within the components, we do have a mechanism by which we can conduct marine repairs and replacements to ensure that the cable can be up and running again as soon as possible.
So when the traffic goes down and we have a fibre break, the larger NOCs within Vodafone will ensure that there is resiliency and traffic switching so that our customers don't see the impact. It'll be a very instant switch away from the fibre that's broken. ahead of a NOC finding a fault or a station staff member finding a fault, we'll make sure that we have the correct things in place. That means having maintenance agreements with vessels so that they're on standby for when things do go wrong.
As we were given a talk by a ship's captain, and to get across the difficulties they face at finding a cable, he likened it to a football pitch. And he said to picture a football pitch, and you put a matchbox in the corner of the football pitch, and then you upend that matchbox, and the matchbox is the ship, and they have to try and find a cable at the bottom of the football pitch using a piece of cotton to find a cable that's the size of the same piece of cotton. So when he likened it to that, you sort of realise the scale of the difficulty in finding these cables. There's no landmarks on the ocean. So you work closely with the ship and the other cable stations, and it could be on a system with a lot of branches, it could be 5 or 6 or 7 other cable stations that you're working with. So there's a lot of coordination to make sure all the systems are powered off correctly, everybody's following the correct safety procedures, and nobody's sending live electricity down to the ship. So some poor guy is about to join the cables with 15,000 volts in it.
We have what we call a repeat offender of the Congo Canyon, which is a underwater canyon that after long periods of rainfall causes a big, they're called turbidity currents, where sediment rushes down through the canyon and wipes out subsea cables at the end of it. But this means that because there's so much sediment running through, it buries the cable really deeply. It's much harder to recover, to repair. And post-repair, we often give this data to researchers like the National Oceanographic Centre so that they can use our data to predict when the next one's going to happen and advancements in climate research and things like that. The turbidity currents in the Congo Canyon were originally predicted to occur once in every 30 years, then once in every 10, and now we're seeing them about once in every 3 years. And this is all due to climate change and the increase in rainfall and therefore the increase in the turbidity currents.
We are undertaking a number of developments that we can provide to look at the sustainability of the marine environment that we lay our cables in. Part of that technology are sensors, if you like, that we can deploy in our subsea cable networks that can measure various factors within the seafloor, such as salinity, the temperature, the pressure, etc., to give us warnings of things such as tsunamis, earthquakes. We really want to make sure that we can get more and more information from our ocean so that we look after it.
So I'm really excited about the future within the subsea industry. First and foremost on the transmission side, the modem side, where Ciena had our latest modem technology becoming generally available. Our WaveLogic 6 able to reach 1.6 tera, which is very, very impressive. On top of that, we are seeing developments on the actual wet plant with increase of number of fiber pairs. We have the spectrum sharing equipment that now creates virtual fiber pairs, which means that we are splitting the cables into smaller pieces and possible to make that a commodity that can be traded between service providers and hyperscalers and between service providers to service providers. The more you want to achieve in this industry, the more you will achieve. There are so many opportunities in this industry.
The industry is a relatively small family of companies that have come together over the years. There's a lot of knowledge that is within those companies right now, but there is a focus that we have, all of us within the subsea cable industry, to bring in new people into the industry, to bring them up to the level that we are now, so that industry can be handed over seamlessly to the next generation.
Early career development is something I'm really passionate about. So from when I was a graduate, the support network wasn't quite as there. So being able to put that in place for the next generation of subsea cable engineers and early career professionals is really important to me. I am one of the co-chairs of the European Submarine Cable Association, ESCA, their next generation working group. The aim of this group is to support early career professionals, driving their skills, upskilling, their networking, and providing opportunities. But also part of what we do is outreach, so getting the industry known from an early level, so primary schools, secondary schools, universities, things like that, just to bridge that skill gap that we have in the industry at the moment.
It's been particularly rewarding working with the graduates as they come through on their graduate scheme, and also with the apprenticeship scheme. And it's been very exciting to see this next level of young talent coming through. The only way to learn is to get involved in projects. The only way to learn is to understand how the cable systems work and how cable stations work.
Day to day, we've taken the apprentice through, when they first arrived, they didn't know what a subsea cable was, to now they're pretty much autonomous in the station. We can give them any task and they're more than confident and capable of operating on it.
The industry will always need the next generation of talent to deliver the same projects that we've been doing all these years.
We have to remember, in this day and age, that up to 98% of all internet traffic is carried across the subsea cable infrastructure that we have put in. I find that tremendous.
With the technology, the boundaries of the physics and science are stretched to try and get as much data as you can down the fibre optic system. It is fascinating. From a commercial viewpoint, it's very interesting. The partners you deal with, quite often they're your competitors, they could be your suppliers, they could be your customers, and potentially it could be all four in one entity. So that makes it very interesting from a commercial viewpoint. And submarine cables are so critical to the world, you know, the political aspects. Most governments want to protect their interests in submarine cable systems, so having that angle also makes it fascinating.